able to remove and refit front bumper and attend for ratting. Remove the headlamp. Remove the bumper mounting bolts to the fender. Remove the wheel guard mounting retainer of bumper side. Installation is the reverse of removal. Remove and refit headlamp and other lamp assembly. Objectives: renew headlamp bulbs, other bulbs. Remove and refit headlight assembly. Removal and installation of heel lamps, turn signal lamp. Disconnect the headlamp connector. Installation is the reverse of removal. Caution: do not touch the surface of the bulb with hands or dirty gloves. Rear combination lamp. Disconnect the battery negative terminal and loosen the rear combination lamp mounting screws. Disconnect the combination lamp connector. Installation is the reverse of removal. Purpose of clutch, gearbox and differential. Objectives: to know the purpose of the clutch unit, the purpose of a gearbox, the purpose of a differential unit, the concept of a trans-axle, the integrated layout of the clutch, gearbox and differential, and to identify the basic components of the clutch, gearbox and differential. The clutch. Transmission clutch performs two tasks. It disengages the engine from the transmission to allow gear changing. It is a means for gradually engaging the engine to the driving wheels. When a vehicle is to be moved from rest, the clutch must engage a stationary gearbox shaft with the engine. This must be rotating at a high speed to provide sufficient power, otherwise the load will be too great and the engine will stall or come to rest. The clutch used depends on the type of gearbox. Automatic gearboxes normally use a fluid clutch which automatically disengages when the engine speed falls below 800 revolutions per minute. Manually operated gearboxes use a dry friction clutch. Friction clutches. A friction plate sandwiched between the engine flywheel and a spring-loaded pressure plate transmits the drive to the gearbox. The extent of the drive is controlled by the force which is clamping the plate. Lowering the driver pedal causes disengagement by separating the friction surfaces. During this operation, the force of the spring is taken by the driver. Initial upward movement of the pedal causes the friction surfaces to contact. Further pedal movement allows the full spring force to act on the driven plate to ensure that all plates rotate at the same speed without any slip. Types of friction clutches. Most friction clutches are of the dry type. That is, they do not run in oil. The clutch will not function effectively if oil gets on the asbestos-based friction lining. Most vehicles use a single plate type because this compact design is efficient, especially as regards to the disengagement. Pressure on the friction plate is obtained by using diaphragm multi-spring assembly. Cars commonly use diaphragm-type clutches. The failure of surface to grip resulting in the driven plate revolver slower than the engine flywheel. In such a case, clutch gets hot and emits an odor. The gearbox. Besides providing forward or reverse motion of a vehicle, the gearbox must overcome one of the drawbacks of the internal combustion engine, that is the poor torque output at low engine speeds. Gearing is provided either to 1. Boost the engine torque, or 2. Enable the engine to be operated at speed where its output power is high. Synchro-mesh. As the name suggests, this type of gear has a synchronization device which equalizes the seeds of the two members that have to be meshed to obtain the gear. The Synchro-mesh gearbox gives a simpler, quieter and quicker gear change. Propeller shafts and universal joints. The propeller shaft transmits the drive from the gearbox main shaft to the final drive pinion. The shaft is long and tubular and balanced to reduce vibration. A shaft connecting the final drive to an independently prung driving road wheel is called a drive shaft. Universal joints. A universal joint is a device to transmit the drive through a varying angle. Axle movement due to bumps in the road cause the distance between the gearbox and the rear axle to alter. A universal joint allows the movement at the sliding flexible joint. Final drive and differential. A conventional transmission has a tubular rear axle to support the weight of the rear of the car. This axle contains the final drive gears, differential and axle shafts. The final drive gear brings down the speed to suit the road wheels and redirects the line of drive. When a vehicle is cornered, the inner wheel moves through a shorter distance than the outer wheel. This means that the inner wheel must slow down and the outer wheel must speed up. During this movement, it is desirable that each driving wheel maintains its driving. This task is performed by a differential. Servicing a vehicle. Objectives: wash and clean a vehicle, grease all grease points with the recommended grease, check and top up the recommended oil in all the units. Job sequence: park the vehicle in the center of the car hoist, close all the door glasses, loosen the wheel nuts 1 or 2 threads. Slowly raise the car house 6 inches above the ground level. Note the tire numbers and positions. Remove the wheel nuts and keep the nuts of each wheel separately to avoid mixing with the other nuts. Remove the wheels. Raise the car to the required height. Provide a safety stand under the side rails. Ensure that all dust and dirt is completely removed. Clean the bottom side of the chassis with the compressed air. Check for the bolts and nuts under the chassis for looseness and any oil leakages. Check the oil level in the gearbox, differential and steering box. If necessary, top up to the required level. Grease the greasing points with the grease gun. Spray anti-corrosive oil under the chassis. Rotate the tires as per the manufacturer's recommendation. Tighten the wheel nuts by hand tightening. Raise the hoist, remove the safety stand and lower the vehicle to the ground. Tighten the opposite wheel nuts at specified torques and remove the vehicle from the hoist. Mix 100 milliliter liquid soap with 5 liters of water. Apply the solution on the body of the vehicle. Clean the body by a car washer with fine spray. Wipe and clean the body with a piece of leather cloth. Check the water level in the radiator, the battery terminal for any corrosion or looseness, the engine oil, the brake fluid level in the master cylinder, the air pressure of the wheels as per specifications, the fan belt tension, lubrication and cooling system and types of lubricants. Objectives: understand why lubrication is needed, how lubrication is done in motor vehicles, understand why cooling is necessary, how cooling is done in vehicles. Engine cooling. Some form of cooling must be provided to take away the heat from the cylinder and working parts of an engine. This heat comes from combustion of the fuel and friction between rubbing parts. An uncooled engine would result in seizure of working parts due to heat expansion, excessive wear, the oil would be burned, pre-ignition of the petrol-air mixture. This means that the mixture would be ignited before time by some red-hot particle in the combustion chamber. There are two methods of cooling: air, liquid. Air cooling. Most motorcycle engines are air-cooled. The principle is to fin the cylinder so as to increase the area of the hot surface exposed to the flow of cool air. This method of cooling is cheap, lightweight, and is not subjected to troubles such as leakage and freezing problems. Airflow for cooling a multi-cylinder engine is provided by a centrifugal fan. This forces the air through the ducted passages and over the fan cylinders. Thermostat. This is a heat-sensitive valve that controls the water temperature by altering the speed of circulation. It is generally fitted on the engine side of the top hose and is preset to stop the water flow to the radiator when the coolant temperature is less than 80 degrees Celsius. Cooling system maintenance. The normal unsealed coolant system should have the coolant level checked and topped up with pure water if possible at weekly intervals. Regular inspection should be made for 1. Leakage of coolant, especially after filling with antifreeze. 2. Cracking or hardening of the flexible hoses. 3. Tightness of the fan belt. 4. Operating pressure of the radiator cap. 5. Correct functioning of the thermostat. Engine lubrication. The friction between two surfaces rubbing together is reduced by using a lubricant to separate the materials. A flow of oil used for this purpose can also be used to carry away an excess heat from the metal parts. The majority of the engines are wet sump system in which the engine sump acts as the reservoir. The friction between the engine components are reduced by boundary lubrication relies on oil being splashed up on the surfaces. Full film lubrication. An oil film is maintained by forcing the oil between the surfaces by an oil pump. The main parts of the lubricating system are pump, driven by camshaft. The pump forces the oil from the sump to the main oil gallery. This runs across the length of the engine. Drillings from the gallery allow oil to be supplied to the bearing surfaces. Relief valve. Generally fitted in the gallery, this spring-loaded valve opens when the pressure reaches the maximum limit. Filters. Screen that prevents the pieces of metal entering the pump. There is an external filter which can be renewed periodically. Servicing air filter, cleaner. Objectives: remove the air cleaner from an engine, clean the filter element. Check the oil level in the air cleaner, fit the air cleaner on the engine. Job sequence: service air cleaner. Unscrew the bolt or wing nut of the air cleaner with the help of a spanner or plier. Remove the top cover with the filter element and gasket. Loosen the nuts. Fixing clip. Fixing the air cleaner on the inlet manifold or carburetor. Remove the bottom case of the air cleaner. Clean the air cleaner housing and cover with the cloth. Inspect the filter element. If it is clogged, replace the same. Check visually the cleaned element for puncture or damage. Discard if it is found punctured or damaged. Check the plastic or rubber ring for smoothness, which acts as a gasket. Installation: place the new or old element in the lower housing. Put the top cover on the element. Tighten the wing nut with the help of a plier. Test the air cleaner by starting the engine for smooth running. Torque techniques procedures. Objectives: Understand the need of standardization. Understand the need of torque specifications. Read and imply torque chart. All nuts and bolts should be tightened to correct torque values. Torquing to a value less than specified results in leaks, looseness, relative movements of parts, vibration, etc. Over-torquing results in damages in threads or fasteners strained to the breaking points. Torque values are based on type of joint, internal pressure to be sealed, vibrations, fastener material, etc. and are specified by all vehicle manufacturers. A torque wrench is a tool which measures the resistance to turning, torquing. There are many torque wrenches available depending on the type of applications. Steps of routine servicing of a battery. Make a visual inspection for defective cables, loose connections, corrosion, cracked cases or covers, loose hold downs and deformed or loose terminal posts. All connections should be tightened and replaced if necessary to ensure proper connection. Corrosion or rust on the hold down, on the terminal posts and the dirt on the battery should be cleaned using scraper and wire brush and a cloth soaked in ammonia or baking soda solution. Emery paper may be used to scrape the mating surface of the clamps and the terminals. The electrolyte levels in all the cells should be checked. If necessary, distilled water should be added to bring the electrolyte to the recommended level. Factors which affect battery life: undercharging, leaving batteries idle, topping up impure water, neglecting topping up, container damage. Specific gravity test. Keep the battery on elevated wooden workbench. Remove all the vent plugs. Hold the hydrometer vertically. Place the nose of the hydrometer in the cell. Ensure that the nose is dipped in the electrolyte. Press the rubber bulb of the hydrometer. Release it to draw the electrolyte upwards. Ensure that the electrolyte does not come into the bulb. Note the float level which is floating in the electrolyte. Record the reading. Repeat the same procedure for all the cells and record the readings. Please note, the reading should not vary more than 25 points between cells. Open circuit voltage test. Connect the leads of the DC voltmeter to the cell terminal. Take the reading from the voltmeter and record. Repeat the procedure for all the cells and record the readings. The voltmeter should read at least 2.2 volts per cell. Recharge, replace the battery if it is in poor condition. High rate discharge test. Hold the handle of the high rate discharge tester. Keep the prods of the high rate discharge tester to individual cell connectors. Press it by hand. Read the voltmeter reading and record in table. The voltmeter should at least read 1.6 to 1.4 volts. Repeat the procedure for all the cells and record the readings. The voltmeter drop should not be more than 1.5 volts in a 6 volts battery with 150 ampere load. Types of brake and steering systems, working principles of drum and disc brakes, objectives. Understand the working principles of a brake system, identify different types of brake systems, identify various components of brake systems, understand the working principles of a steering system, identify different types of steering boxes, identify various components of steering box and its linkages. The steering system. The type of steering layout depends on the suspension system. The beam axle used on heavy commercial vehicles has a kingpin fitted at each of the axle, and this pin is the pivot which allows the wheels to be steered. Cars have independent suspension. This system has ball joint to allow the wheel movement. Power-assisted steering. Power-assisted steering systems use hydraulic power to help the driver turn the road wheels when the steering load exceeds normal. Types of brakes. Drum brakes, disc brakes. Drum brakes. These types of brakes have two shoes anchored to a stationary backplate which are internally expanded to contact the drum by hydraulic cylinders or a mechanical linkage. The end at which the shoe is anchored affects the retarding force it applies to the drum. The rotation of the drum gives a self-energizing action called the self-servo, which causes 1. Leading shoe to be forced towards the drum, 2. Trailing shoe to be forced away from the drum. The leading shoe is the first shoe after the expander in the direction of rotation. Disc brakes. Exposed to the air, disc brakes radiate the heat to the air better than drum brakes. This means that the brake can be operated continuously for a long period as they have a greater resistance to fade, or in other words, fall off in brake efficiency due to heat. This fade resistance and features such as automatic adjustment make the disc brake a popular choice for the front wheels of a car. A vacuum servo fitted to the discs boosts the effort applied by the driver. Adjust handbrake and replace handbrake cables and adjust clutch and brake pedal. Objectives. Adjust handbrake for effective handbrake application. Replace handbrake cable if old cable found to be out of adjustment range. Adjust the free play of a clutch and brake pedal to recommend free play range. Components. Show the components of handbrake cables. Removal. Remove the console box. Loosen the adjusting nut and detach the parking brake cable. Detach the parking brake switch assembly. Remove the wheel and tire. Remove the brake drum. Remove the brake shoes as outlined before. Detach the parking brake cable from the brake shoe. Remove the rear seat cushion assembly and roll up the carpet. Loosen the parking brake cable clamp and remove the parking brake cable assembly. Inspection. Check the parking brake switch operation. Check the parking brake lever ratchet for wear. Check the parking brake cable for fraying or damage. Using a standard screwdriver and tightening locking devices. Objectives. Handle a screwdriver and use it. Use different types of locking devices correctly using a screwdriver. Select the correct size screwdriver to suit the screw slot. Select the longest suitable screwdriver with that size of tip. Hold the screwdriver with its axis in line with the axis of the screw. Guide the blade with the left hand. Apply a little pressure with the right hand to keep the tip in the slot. Twist firmly and steadily. Keep the tip centered in the slot and the axis of the blade in line with the axis of the screw. To turn large screws, use a screwdriver with a square blade. Apply extra twisting force with the aid of a close-fitting spanner. Never use pliers or toothed wrenches to apply twisting force to a screwdriver. A standard screwdriver blade should be ground to 9 degrees so that the faces will be almost parallel with the sides of the screw slot. The end of the blade should be made as thick as the slot in the screw will permit. Do not grind the blade to a chisel point as it has a tendency to slip out of the screw slot. Tightening locking devices. Job sequence. Split pin. Tighten the nut at the specified torque. Check the bolt's holes and nut's slot alignment if not aligned. Sling the hole by tightening the nut slightly. Insert a new suitable split pin in the slot and hole. Drive the split pin fully inside. Spread open the slide of the split pins and bend it on the nut. Inside circlip or snap ring. Hold an internal circlip with the help of an internal circlip plier. Press the circlip with the help of the plier so that the diameter will be smaller than the hole diameter. In this position, insert the circlip in such a manner that it will sit squarely in the groove. Take out the plier. Outside circlip or snap ring. Hold an outside circlip with the help of an external circlip plier. Press the external circlip plier so that the circlip will enlarge in diameter. In the enlarged position of circlip, slide it on the shaft. While sliding, set it in the shaft groove. Ensure that the circlip sits squarely in the groove. Take out the plier. Wire ring hose clamp. Clean the outside surface where the hose pipe is to be set. Apply grease inside the starting end surface for easy insertion. Set the wire spring hose clamp on the hose pipe. Slide the hose pipe on the metal pipe. Press the hose clamp with the help of a plier and slide it on the joint of the hose pipe and metal pipe. Take out the plier. Working principle of 4-stroke petrol and diesel engine. Objectives: understand how a 4-stroke petrol and diesel engine works. Know how an engine can be called 4 or 2-stroke engine. Operating principles of engines. Gas expansion. When a gas is heated, it tries to expand. If this expansion is resisted, then a high pressure is built up, which in turn creates a large force. A mixture of petrol and air compressed in a container or a cylinder makes an explosive gas. When the gas is ignited, the pressure moves the piston towards the open end of the cylinder. Linking the piston by a connecting rod to a cranked shaft causes the gas to rotate the shaft through half a turn. The power stroke uses up the gas, so means must be provided to expel the burned gas and recharge the cylinder with fresh petrol-air mixture. The valves control the movement of gas. An inlet valve allows the new mixture to enter at the right time. An exhaust valve lets out the burned gas. A flywheel and its need. A flywheel is needed to drive the crankshaft during the time that the engine is performing the non-power strokes. The flywheel carries the engine over the non-working strokes. Multi-cylinder engines. A smoother flow of power from the crankshaft is obtained when more than one cylinder is used. The extra power impulses are spaced out evenly throughout the 2 revolutions of the 4-stroke cycle. The flywheel of a multi-cylinder engine is lighter in weight. Inline engines. The cylinders are placed in a single row. Twin cylinders. Twin cylinders are used in motorcycles and some small cars. 1 power stroke of every 360 degrees of crankshaft movement. 4 cylinders are commonly used in cars to give good balance to the crankshaft. Differences between petrol and diesel engines. Objectives: know the differences between a petrol engine and a diesel engine. Compression ignition engines. CI engines. This engine is commonly called a diesel engine. It gets this name from the pioneer work done by Dr. Rudolf Diesel. The diesel is used for the majority of heavy vehicles, and an excellent fuel economy makes it an attractive alternative to the petrol engine for light commercial vehicles, delivery vans, and taxis. Most of these vehicles use a 4-stroke engine, but 2-stroke operations is favored by a number of heavy vehicle operators. Compared to the petrol engine, the CI engine is different in the following ways. Induction. During the induction stroke, only air is supplied and a full unthrottled charge is induced. Compression. The air is more compressed. The typical compression ratio of a petrol engine is 9:1. The ratio of a CI engine is about 16:1. This high compression results in the air being very hot at the end of the compression stroke. Fuel supply. The fuel is special gas oil called DERV, diesel engine road vehicle. It is pumped in very high pressure into the cylinder when the piston nearing the end of the compression stroke. Power output is controlled by regulating the quantity of fuel injected. Ignition. No electrical spark is necessary since the high temperature of the air in the cylinder is sufficient to fire the fuel oil as it is injected. Engine construction. High cylinder pressure demands a more robust engine construction. A governor is fitted to limit the engine speed to a safe figure. 4-stroke CI operating cycle. Spread over 2 crankshaft revolutions or 720 degrees, the 4 strokes are induction, compression, power, exhaust. Valve operation and timing is similar to the petrol engine. 2-stroke CI operating cycle. This operating cycle has a power stroke every revolution. The cycle completes in 1 crankshaft revolution or 360 degrees. 4-stroke engine on CI principle overcomes one of the main disadvantages of a 2-stroke petrol engine: the loss of fuel when the transfer and exhaust ports are open at the same time. Wheels, tires and steering troubles. Objectives: rectify abnormal wear of tire, rectify wheel wobbling, rectify poor self-centering, rectify hard steering, rectify trouble of vehicles pulling to one side. Job sequence: abnormal wear of tires, front and rear. Tire inflation: inflate if not inflated at corrected pressure. Toe in, toe out, adjust if not adjusted correctly. Bearings: replace if found damaged. Hub end play: adjust if found excessive. Kingpin bushes: replace if found worn out. Kingpin end play: adjust if found excessive. Axle beam: replace if found bent, twisted. Brake binding: adjust brakes if binding is found. Chassis frame: replace if found twisted, bent. Poor self-centering: check the following. Steering linkages: lubricate if found unlubricated. Tire pressure: inflate if not inflated at correct pressure. Wheel alignment: align if not aligned. Steering's inner columns preload adjust if found excessive. Adjustment between steering gear and worn: adjust if not adjusted properly. Hard steering: check the following. Tire pressure: inflate if not inflated properly. Tire size: use tire of recommended size if found wrong sizes tire fitted. Oil level in steering gearbox: top up if found less. Preload of steering inner column: adjust if found excessive. Drag link: replace if found bent. Vehicle pulling to one side: check the following. Tires: replace if found unequally worn out. Drag link: tie rod: replace if found bent. Center bolt of spring: tighten if found loose. Spring bushes: replace if found worn out.
Repair and overhauling of two-wheelers. Moped.
Welcome viewers. In this video, you will know how to repair and overhauling of two-wheelers, moped.
Exercise 13.01. Measure any component by using micrometer and dial gauge.
Hello viewers. At the end of this exercise, you will know how to measure the dimension of a component using inside micrometer, measure the dimension of a component using outside micrometer, measure the flatness, straightness and ovality of a surface using a dial gauge.
The purpose of a metric micrometer is to read an accuracy of 0.01 millimeter of an object. Inside micrometer. The inside micrometer is similar to an ordinary outside micrometer but without the U frame. The measurement is taken over the contact points. As the thimble opens or closes, the contact points get opened or closed. To measure the approximate size of a hole or slot, select a suitable range of telescopic range. Press the moving leg gently and lock the telescopic gauge. Place it inside the hole. Release the pressure and allow both the legs to touch on the wall of the hole. Keep the telescopic gauge perpendicular to the diameter of the hole. Move the gauge slightly inside the hole and get the correct feel. Lock the telescopic gauge. Remove it gently from the hole. Transfer the measurement to an outside micrometer and read it. When the inside micrometer is closed, when 0 of thimble coincides with 0 of the barrel, it is capable of reading the minimum dimension of 25 millimeter. Inside micrometer with a spacing collar and extension rod of 125 to 150 millimeter range. The size of the bore is 125 millimeters plus 12 millimeters plus 1.5 millimeters plus 0.00 is equal to 138.50 millimeters. Determining the distance between internal parallel surfaces. While checking the parallelism between two surfaces of a deep bore, a handle must be used along with inside micrometer. In order to ascertain parallelism, a minimum of 2 readings has to be taken. Determining the dimension of the hole. Fix the handle to the micrometer. Turn the micrometer thimble with the thumb and finger slightly so that the distance between the measuring faces is less than the hole size, and pass the micrometer head through the hole. Open out the thimble further until you feel the anvil just touching the surface. Several thimble readings have to be made before arriving at the correct size. For exact measurement, use the front anvil as the pivot. Move the body of the micrometer through the hole. Pass the anvil through the anvil holes several times to ensure that the measurement is being taken directly through the center. Lift the micrometer carefully from the hole and measure the dimension of the hole. Total reading is equal to reading on the barrel, minimum measuring range. Similarly, it is possible to take the inside measurement of a machined component by above method. If the hole size is more than 38 millimeters diameter, use a 12 millimeter spacing collar along with the existing extension rod. Loosen the clamping screw. Release the extension rod from the barrel head. Wipe the locating faces on the collar and barrel. Insert the extension rod into the 12 mm spacing collar and assemble to the barrel with the collar. Clamp the extension rod firmly with the clamping screw and check the size with the same size of an outside micrometer. Read the measurement taken on the barrel. A 3-point internal micrometer is used for direct measurement of an internal diameter accurately and efficiently. It is also used to measure the diameter of a deep hole, the end of a blind hole. Dial gauges. Dial gauges are instruments of high precision, used for comparing and determining the variation in the size of a component. They cannot give the direct reading of the sizes like micrometers and vernier calipers. Dial gauge magnifies small variations in sizes by means of a pointer on a graduated dial to check the straightness of shafts. Place the dial gauge over the surface of the cam shaft and check for cam lobe surface wear by gently rotating cam shaft. If the dial gauge shows any variation between different points, take suitable corrective action. To check plane surfaces for parallelism and flatness, introduce the dial gauge inside the cylinder bore and gently move across the cylinder in different directions. Note down the dial gauge readings and take suitable corrective action if necessary. To measure crankshaft eccentricity and ovality, place the crankshaft on a holding device and gently move the dial gauge over the crankshaft journals, bearing journals, etc. Note down the readings in the dial gauge and take suitable corrective action if necessary. The various other applications of dial gauge are shown.
Hello viewers, in this exercise you have learned how to measure the dimension of a component using inside micrometer, measure the dimension of a component using outside micrometer, measure the flatness, straightness and ovality of the surface using a dial gauge.
Exercise 13.02. Remove broken stud.
Hello viewers, at the end of this exercise, you will know how to remove different broken parts of the vehicle, list out the tools used for removing a broken stud, finish off the broken stud for removing by drilling, remove the broken stud by a tap, and remove the broken stud by an easy extractor.
The stud is used in the place of a bolt where a hole cannot be head for the bolt to pass through or to avoid the use of an unnecessary long bolt. Studs are generally used to fix up cover plates or to connect cylinder covers to engine covers. Procedure to remove stud below the surface. File flat on the top surface of the stud. Locate the center and center punch it. Select the easy out and recommended drill size. Drill a hole on the center punch mark. Ensure the hole is perpendicular. Set the easy out stud extractor on the drilled hole. Turn it anti-clockwise by tap wrench. As the easy out penetrates into the stud, the grip increases and gradually the broken stud portion unscrews. Replace a new stud in position after lubricating the threads. Making drill hole. Correctly find out the center of the broken stud and drill a hole of diameter little less than the core diameter of the stud down the center so that the threads only remain. Remove the thread portion by the point of a scriber in the form of broken chips. Retap the drilled hole to clear the threads. Prick punch method. If the stud is broken very near to the surface, drive it in an anti-clockwise direction using a hammer and center punch to remove it. Removing broken stud above the surface. File two sides of the stud flat above the surface. Use a wrench and unscrew to remove the broken stud out. To remove the broken stud or bolt below the surface, a stud extractor is to be used. Locate the center of the broken stud. Center punch it. Drill in the center of the broken stud by using a drill of diameter little less than the root diameter of the thread on stud. Use the right easy out number of the extractor. Turn the extractor to force out the broken part of the stud. File square form. When the stud is broken a little above the surface, form a square on the projecting portion by means of a flat file to suit a standard spanner. Then turn it anti-clockwise using a spanner to remove it. Using a square taper punch. Broken studs can be also removed by drilling a blind hole. Hole diameter equal to half of stud diameter. And driving a square taper punch into the hole. Turn the punch using suitable spanner in an anti-clockwise direction to unscrew the stud. If all other methods fail, drill a hole equal to the size of the stud size and tap the hole with an oversized tap. Recommended drill and easy out size for the extraction of broken stud and bolt.
Hello viewers, now you know how to remove the different broken parts of the vehicle, list out the tools used for removing a broken stud, finish a broken stud for removing by drilling, remove a broken stud using a tap, remove a broken stud using an easy extractor.
Exercise 13.03. Dismantle, clean, check, assemble and adjust carburetor.
Hello viewers, at the end of this exercise, you will know how to dismantle a carburetor, list out the components of a carburetor, clean the carburetor and its parts, check the working of the float, main and idling jet, assemble the parts of a carburetor, adjust the idling screw and air bleeding screw in a carburetor.
Task 1. Dismantle a carburetor. Locate the carburetor. It will be below the fuel tank. Wipe any dust, oil on the carburetor with a clean cloth. Close the fuel tap to prevent wastage of fuel due to overflow when the fuel filter hose is removed. Use suitable double spanner to loosen the nuts connecting the carburetor to the inlet manifold. Use the suitable screwdriver to loosen the screws connecting the carburetor to the air filter unit. Loosen the throttle cable using a suitable cutting plier. Loosen the choke lever cable using a suitable spanner. Remove the carburetor and place it in a clean container or tray. Loosen the float chamber securing screws. Remove the fuel overflow hose from the bottom. Remove the seal and place it in a secured place. Remove the idling screw or jet and air screw. Remove all the components like primary or main jet, float, pin and lock, etc. and put it in the tray. Task 2. Clean the carburetor. Collect about 50 ml petrol from the tank by opening the fuel tap and clean all the components thoroughly. Kerosene may also be used. Check the main jet for any block, insert a small wire, clean the gap and blow compressed air to remove any dust. Check the float for any puncture. A punctured float may not function properly and may lead to wastage of fuel by not closing the fuel supply once the sump is full. Replace the float if necessary. Blow compressed air over the carburetor thoroughly to remove any dirt or moisture. Task 3. Assemble the parts of the carburetor. Assemble the components one by one in the reverse order. Check the float. Connect the float. Main jet. Air bleeding screw and overflowing hose. Connect the throttle cable and choke lever. Connect the carburetor to intake manifold and tighten the lock nuts using suitable DE spanner. Check whether they are operating normally by pulling them. Connect the air filter unit. Connect the fuel inlet hose and open the fuel tap, allowing fuel to flow into the carburetor. Wait for 2 minutes and start the engine and allow it to warm up. Task 4. Adjust the idling screw and air bleeding screw in a carburetor. Adjust the idling screw to make sure that the engine rotates. Crankshaft at 1500 RPM. Under cold conditions, set the idling at 1300 RPM, which will increase when the engine warms up. Check the engine speed with the help of a crankshaft. Also adjust the air bleeding screw suitably. Take a test drive and do corrective action if necessary.
Hello viewers, now you have learned how to dismantle a carburetor, list the components of a carburetor, clean the parts of a carburetor, check the working of a float, main and idling jet, assemble the parts of a carburetor and adjusting the idle screw and air bleeding screw in a carburetor.
Exercise 13.04. Clean intake and exhaust system.
Hello viewers, at the end of this exercise, you will be able to list out the parts of the intake system and exhaust system, remove and clean the intake system and exhaust system.
Intake system. Intake system consists of inlet manifold and air filter. Using suitable screwdriver, loosen the screws secured to the carburetor and remove the air filter assembly. Dismantle the air filter assembly by pulling the securing lock. Take out the air filter element and clean it with a dry cloth. Gently blow compressed air at reduced pressure. High pressures may damage the air filter element. Replace the air filter element if the recommended replace interval is reached. Refer to service manual for details. Attach the filter unit to the assembly. Secure the air filter screws tightly by means of a screwdriver. Using suitable DE spanner, remove the inlet manifold from the carburetor and clean it with a neat, dry cloth. Check for any crack or distortion. Remove the fuel filter by loosening the locking pin and clean it thoroughly. Replace the fuel filter hose if it is worn or damaged. Attach the filter and secure it with the lock pin. Attach the manifold to the engine and carburetor with a suitable DE spanner. Exhaust system. With the help of a screwdriver or puller, remove the muffler assembly from the exhaust pipe. Loosen the securing nut from the exhaust pipe using suitable DE spanner and take out the exhaust pipe. Using a suitable screwdriver, remove the heat shield. Use a suitable scraping tool for removing carbon deposits on the exhaust pipe walls. Clean and remove the carbon deposits thoroughly from the exhaust pipe and muffler assembly. Sometimes the deposits will be very hard to remove. In this case, using a suitable solvent burn the muffler assembly for about 10 to 15 minutes for all the carbon deposits to burn up. Once again, scrap the carbon built up in the exhaust thoroughly. Now, it will be easy to remove the carbon layer due to heating. Gently tap the muffler assembly to the floor to remove any carbon particles inside. Also blow compressed air over the muffler and exhaust pipe. After ensuring thoroughly cleaning of the exhaust pipe and muffler assembly, attach them to the exhaust manifold using suitable DE spanner or screwdriver.
Hello viewers, now you know how to list the parts of the intake system and exhaust system, remove and clean the intake system and exhaust system.
Namaskar and a very good morning. I am K.K. Mishra from Ministry of Power, Government of India. and I'm here to discuss and talk about the various initiatives taken by Government of India, Ministry of Power regarding digital initiatives. This is a creation of an ecosystem which enables consumer not only to facilitate the various services but also empower and